Huh? The CCTV is 120 meters away? I can just use a LAN repeater. If you thought that, hold on a second and watch my video. A LAN repeater, or Ethernet repeater, may seem like a simple extension. But it's definitely a very useful device that can easily connect distances over 100 meters. However, once you actually use it, you'll realize there are quite a few things to be careful about. If you're not careful, network speed may suddenly drop. You might encounter unexpected power issues. And you could even end up spending a lot of money without seeing any results. Today, I will share some anecdotes from my own experiences, along with essential tips you need to know to safely and efficiently extend your LAN cable. First, shall we go over the basic roles of the LAN cable and the repeater? A LAN cable refers to the Internet cable we commonly see around us, and Ethernet refers to the communication protocol that allows data to be transmitted through this cable. Ethernet cables generally guarantee stable data transmission up to 100 meters. Of course, the 100-meter distance is based on technical standards. And in real environments, cable quality, surrounding electromagnetic interference, and even environmental factors, such as temperature and humidity, can cause performance to vary slightly. However, if this standard is exceeded, signal attenuation increases sharply, leading to a decline in communication quality or even complete disconnection. But what should we do if we need to connect the network over a distance greater than 100 meters, for example, 120 meters, 150 meters, or even up to 200 meters? What comes into play at this point is the LAN cable repeater. A repeater is a device that repeats the signal to transmit it over long distances, just as its name suggests. By receiving weakened electrical signals and amplifying them, it not only amplifies the signals, but also restores lost or distorted signals to their original clean form, and regenerates them into new signals to send to the next segment, theoretically allowing the network to be extended over greater distances. In this process, the repeater plays a crucial role in maintaining signal integrity and minimizing data loss. Shall we start with an interesting experiment I experienced? In a previous project, we had to install CCTV, but the distance from the installation site to the recorder was quite far. When I measured it accurately, it turned out to be about 120 meters. I confidently thought, oh, a single LAN repeater should be enough, and purchased and installed the repeater. At first, it seemed to be working well. The CCTV footage was coming through nicely, and data appeared to be transmitted normally. However, problems began to arise after a few days. The CCTV feed would intermittently cut out, image quality would degrade, and there were even times when it completely stopped working. At first, I thought it was an issue with the CCTV camera itself, or perhaps a problem with the network recorder. I spent days troubleshooting, checking connections, swapping out cables, and updating firmware, but the problem persisted. The intermittent nature of the failures was particularly frustrating, making it difficult to pinpoint the exact cause. It would work perfectly for a few hours, then suddenly drop out, only to miraculously recover later. This unpredictable behavior is often a hallmark of signal integrity issues, something I would come to understand much better. I eventually discovered that the issue was not with the camera or the recorder, but with the repeater installation itself. My initial thought that a single LAN repeater should be enough was fundamentally flawed. The problem lay in several factors I hadn't considered. One major oversight was the power supply to the repeater. Many LAN repeaters require a stable and sufficient power source, while some can be powered over Ethernet PoE. Not all setups provide adequate power over such extended distances, especially when combined with the power demands of a high-resolution CCTV camera. I had assumed that since data was passing through, power was also sufficient, but this was a naive assumption. Another critical factor was cumulative signal degradation. While a repeater does regenerate the signal, it's not a perfect process. Each regeneration introduces tiny latency and can potentially add noise, even if it's designed to clean the signal. When pushing cable length limits, these minor imperfections can accumulate and become significant. my 120-meter run, though just a bit over the 100-meter standard, was enough to expose these vulnerabilities. Especially under continuous CCTV data stream, the quality of the LAN cable itself also plays a huge role. I had used a standard Category 5E cable, but for extended runs beyond the official standard, higher grade cables like Category 6 or even Category 6A can make a substantial difference in reducing signal attenuation and crosstalk. Electromagnetic interference EMI from nearby power lines or machinery can also subtly degrade the signal, and this effect becomes more pronounced over longer distances. My repeater was in an industrial environment, where various electrical noises were present, contributing to the problem. What I learned from this experience is that simply installing a repeater isn't a magic bullet. There are crucial considerations beyond just plugging it in. One of the most important is power. Many repeaters need external power, and if using PO, you must ensure the power budget is sufficient for both the repeater and any connected devices, like IP cameras. For longer distances, a dedicated power supply near the repeater is often the most reliable solution. Another tip is to consider the type of repeater. Not all repeaters are equal. Some are designed for simple data extension, while others offer more robust signal regeneration and support for higher data rates. Matching the repeater to your network speed requirements is essential. Using a repeater designed for 100 megabits per second when you need gigabit speeds will obviously bottleneck your network. Furthermore, don't underestimate the quality of your cabling. While a repeater can extend the reach, it cannot fix a fundamentally poor cable. Always use high-quality cables, especially for runs approaching or exceeding the 100-meter limit. Shielded cables STP can help mitigate electromagnetic interference in noisy environments. Also, think about the environment where the repeater is installed. Is it exposed to extreme temperatures, moisture, or dust? Industrial grade repeaters with appropriate IP ratings are crucial for harsh conditions. My CCTV setup was in a semi-exposed area, and I hadn't fully considered the impact of environmental factors. The constant temperature fluctuations and occasional humidity likely contributed to the intermittent failures. Lastly, always test your setup thoroughly after installation and monitor it over time. Intermittent issues can be the most challenging to diagnose, but careful monitoring of network performance metrics, like packet loss and latency, can provide early warnings. Had I implemented more rigorous monitoring, I might have identified the underlying issues sooner. In summary, while LAN repeaters are incredibly useful for extending network distances, they are not a one-size-fits-all solution. Careful planning, considering power, cable quality, environmental factors, and thorough testing are all vital steps to ensure a stable and reliable extended network connection. Don't make the same mistakes I did. Learn from my anecdotes and save yourself time, money, and frustration. By paying attention to these details, you can successfully deploy your LAN repeaters and achieve seamless network connectivity over greater distances. Making sure your CCTV or any other network device works flawlessly every time